So after 50, our next question is a 22nd question. That one is a superposition theorem. So this superposition theorem is a very simple theorem. So compared to Thevenin's theorem and Norton's theorem. Here we have two conditions, case 1 and case 2. So based on that case 1 and case 2, we are calculating individual current sources. That current source we can combine in third case. Okay, simply. So three cases available in this superposition theorem. In first case we are calculating I1 current, second case we are calculating I2 current, and third case we are add those I1 current and I2 current simply. And here also the statement is very simplified and smallest statement here. For any bilateral network, we can check the individual source performance. That individual sources performance equal to a total response of the network. So you remember previous case Thevenin's theorem and Norton's theorem. There is no any bilateral network also we can solve Thevenin's theorem and Norton's theorem. It should be a mandatory to take a bilateral network. For bilateral network only we are going to calculate the superposition theorem. Because bilateral means at least minimum two or more than sources in the given network. Okay, or otherwise we are not calculating individual sources. Okay, you remember for this superposition theorem bilateral network is mandatory. For a Thevenin's theorem, Norton's theorem, no need of bilateral network also, it will be possibility to calculate. For a superposition theorem should be a mandatory bilateral network. Okay, bilateral means at least minimum two sources. Okay, two or more than sources. Okay, so you remember here according to this statement we are taking two voltage sources, here V1 voltage source and here V2 voltage source we are taking according to statement. Okay, so in this loop we are taking I1 current, in this loop we are taking I2 current, and remaining all the resistances are same. So we are calculating individually. If any case V1 source we are taking and V2 source we can do a short circuit condition. At the time we are calculating I1 current, because whenever we done a short circuit, in the sense in that particular condition current is very high and voltage is 0 simply. So that's why we are calculating I1 current only by using this V1 voltage source. And the second case V2 source we are taking and V1 source we will be going to do a short circuit. Then at the time we are calculating I2 current. So these two currents we are adding in third case, we are getting total response I current. Okay, so it's mean at a time we are taking these two voltage sources, then what is the response? I1 current and I2 current we are adding, in the sense we can get it total response. So that is the superposition theorem statement. Then we will go for first case. So what is that first case? Whenever source voltage V1 acting alone, at that time second source V2 is in short circuit condition. So it's mean V1 source we are taking and V2 source in short circuit condition. That's why V2 voltage is simply a 0, and remaining all the resistances are same. There is no any change in the resistance value. Then simply we can solve this network by using current division rule. Okay, by using current division rule we are calculating I1 current. So I1 current is equal to total current into opposite resistance by total resistance. It's simply always I remember, once again I am going to remember, where we done a short circuit, from that place only we are taking opposite resistance and total resistance. Here opposite resistance is R2, so total resistance in the sense R1 and R2 and R3. So that values only I have mentioned here. Total current IT and opposite resistance by total resistance. Okay. So total current, how we are going to calculate total current? IT is equal to V1 by equivalent resistance. V1 is a source voltage, which source is acting in the network. So V1 only acting in the network. So that's why that V1 voltage source we are going to take here, and total equivalent resistance we are going to calculate. R equivalent is equal to parallel resistances R3 into R2 by R3 plus R2 plus series resistance R1. Okay, same whatever the resistances we are taking in previously Thevenin's theorem and Norton's theorem, the same formulas only. Okay, and the second condition, whenever source V2 is acting alone, at that time first source V1 is in short circuit condition. It's mean previously in first case V1 source we are taking, V2 in short circuit condition. In this case V2 is acting alone and V1 is in short circuit condition. The same formulas will not change. So it's mean you remember case 1 formulas, the same formulas you have to write it here, but you have to change only current only. So previous case you have taken I1 current, but here you have to take I2 current. So I2 current is equal to total current into opposite resistance by total resistance. The same formula, there is no any change. But here the opposite resistance will be changed, because here opposite resistance where we done short circuit in this side, that's why opposite resistance these two are only. So for these two resistances only we are going to write it. So we are applying that current division rule for these two resistances. So I2 equal to IT into R1 by R1 plus R2. So same formula IT, but previous condition V1 by R equivalent resistance you have written. Okay, but here you have to write it RT is equal to V2 by R equivalent. So it's because here acting source voltage 2, no, that's why only. And R equivalent resistance is same, but here we are applying it for these two resistances. Previously we are applying for these two resistances. So whenever we are doing these two resistances, we are going to take this current only, this loop current only we are taking, I1 current. Whenever we are going to do this one is a short circuit condition, we are going to take this loop current. That's it. That's why we are going to take here these two resistances, and this is R3 is in series. Then we will go for third condition. So when both V1 and V2 sources acting alone at a time. So whenever these V1 voltage and V2 voltage, these two are acting at a time, then we can get it total response I equal to I1 plus I2. These two current values we can add here, I2 current and as well as I1 current in a sense. Then we can get the total response. That's it. This is the superposition theorem. Okay, you remember always.